Okay, so here in this experiment question, we will be talking about like how to design an investigation, how to design an experiment, how to design, an experiment, or you may also say, or plan an investigation, right? So how to design an experiment or how to plan an investigation. This is what we're gonna do in this question. Guys, before we go to plan this experiment, I wanna give you some general points that you will be considering for designing any kind of experiment or for planning any investigation. What are those points? I will be noting them down here on the right side. Okay, what are they? Here, what is that? Let me put it up here. We will be talking about 3 variables. Okay, what are they? Independent variable. Yes, independent variable. Dependent variable. And constant variable. These are the 3 variables that we will be talking about. We need to design an experiment so we can do it properly. Now when we are putting about these 3 of them, these 3 variables, we will be talking about their apparatus. Which apparatus I'm using for independent variable, which apparatus I'm using for dependent variable, and which apparatus I'll use for constant variables. Means I will be talking about apparatus. I will bring all these points later, when we do this example. So I will tell you how I am gonna put it here. Then, other than that, I will be giving you some common points that, you are going to put. So let's, talk about it first. When, we are talking about 3 variables, independent variable is the one which is always under investigation. Okay, it is the one that we are going to make, we are going to change. Okay, so here let's read the question. The rate of reaction between magnesium and dilute hydrochloric acid can be followed by measuring the volume of hydrogen produced. Okay, correct. We already know metal reacts with acid, magnesium reacting with hydrochloric acid, forming magnesium chloride and hydrogen gas. So one of the product is gas, which can be used to measure the rate of reaction. Now, plan an experiment. Okay, to investigate what? To investigate the effect of decreasing temperature. So it means we have to use different temperatures, right, in order to investigate this, right, what they are asking. So here, this should be my first point that, I am going to use. So what I am going to use, I am going to make different temperatures, right? Okay, prepare different temperatures. Okay, commonly 3 to 5 range can be given. Okay, so prepare different temperatures. For example, which one you are saying? Okay, you may talk about 20 degrees Celsius, 30 degrees Celsius, okay, and 40 degrees Celsius. 3 to 5 different ranges you can give. Now how you are going to do? Using water baths. Okay, using water bath. How? With beaker and thermometer, right? Okay, you can use that. So this is your very first point, means your independent variable is done, right? Independent variable is done. I will be, connecting it. Now next, you are provided with magnesium ribbon, dilute hydrochloric acid, and common laboratory apparatus. So now here, before we go for dependent variable, Okay, that is the amount of gas, right? Let's talk about constant variable that we are going to use. So what are you going to use? The very next point, I'm changing different colors so they will not mix up. What you are going to use, you are going to, okay, use pipette to measure, let's say 5 ml, okay, or 10 ml, okay, 5 ml, 10 ml, okay, for each of the 10 ml of HCl for each of the experiment. Which experiment? One for 20 degrees Celsius, one for 30, and one for 40. You have 3 experiments to do, right? So use pipette to measure and 10 ml of HCl for each of the experiment, right? Then so here also what you have done, you have already told that you are going to use that. Then next also, how about magnesium ribbon? Magnesium ribbon also you are going to take equal length of it. Okay, for example, you are going to say take 5 cm, okay, 5 cm of magnesium ribbon for each of the 3 experiments. You may use ruler, right? Your small ruler also can be used to measure magnesium ribbon, right? So this is what here I have actually covered 2 points, right? So what are these 2 points? These 2 points will go for constant variable, right? Everybody agrees, right? This is how it is going to go. Now, my main point that I have to go for my dependent variable. I know one of the product is gas, right? So what I can use measuring cylinder, measuring cylinder. Yes, that can also be used, or gas syringe, right? That is usually the most common apparatus that we use. Okay, let me put up here. Now, actually, you need to explain it, right? So what are you going to do? You are going to add magnesium ribbon in the conical flask and HCl. Then what you are going to do, connect it with the gas syringe. It would be better, if you may also talk about to pour, via funnel. Okay, so that will also be better. So like, your gas will not be escaped. So add magnesium ribbon in the conical flask and HCl and connect it with the gas syringe. Okay, to do what? To measure the volume of gas, to measure the volume of gas produced in each experiment. Here, also you will keep the timing same, right? So what you will say, make sure to collect the gas reading, means what is being produced every minute or every 30 seconds also can. Okay, every minute or every 30 seconds, but whatever you are writing, it should be the same, means you are going to keep the same time for collection of gases. This will also actually fall under what? Under constant variable, right? Where you are going to keep the equal amount of time for all the experiments, right? Now what you are going to do, you are going to make conclusion. Okay, what should be your conclusion, or you can say result, right? Here, conclusion, or we may also call it result. What is it gonna be? Okay, rate of reaction, because this is what we are doing on rate of reaction. So we must conclude what they were asking us in the question. So rate of reaction is higher at higher temperatures because quicker, faster collection of gases, right? Quicker collection of gas at faster, at higher temperature. Okay, similarly, at lower temperature, it will be slower, right? This is one point. Then again, one common point that will qualify you, Mark, repeating the experiment. Okay, so here, this will also be the common point. Repeat the experiment. This will also qualify you for 1 mark. Repeat the experiment to find average. Also, one common point that I want to give you is about safety precaution. That is also good, to add your marks. Safety precaution. So safety precaution, also you may talk about what here, since, you are using acid, okay, which is corrosive. So, you may talk about safety goggles, right? Even goggles, glass, general, safety precautions you can give, right? Gloves, even lab coats, right? Yeah. So these are some of the common points, and these are very general points which are actually, applicable most of the time, right? Where, you can talk about that how, these experiments, these lab coats, goggles, gloves can be used, because most of the experiments would need that. These are common safety precautions. Other than that, repeating the experiment is also a very common point that is applicable actually for all 3 sciences, not only for chemistry. Okay, and do not forget to give the conclusion. Of course, it will be according to the experiment what is under investigation, right? So if you are smart enough to evaluate your independent, dependent, and constant variables, your designing the experiment is gonna be superb. It is gonna be perfect. Okay, yeah. So consider these points, and definitely it is gonna help you design a very good experiment.